Okay, so here we have the next question on the menu today, which is asking us, with the vector sum a plus b plus c, all vectors. So let's write this out as we go. A plus vector b is equivalent to vector c. And we are given vector a, which is like this. Vector a is 13.5 meters with an angle of 37 degrees. And so it's clockwise, so it's like this. From the x-axis, okay. And vector c is given as 15 meters, and it is angled 26.5 degrees. .5 degrees counterclockwise from the negative x direction. That is critically important, negative x direction. Okay, so this is going this way. Okay, so another way that we can write this is 206.5 degrees, because if we just add 180 to it, that would be the same as 200.6. Okay, and we have to find out what is the magnitude and angle of b. Okay, so essentially what we have here is we're trying to isolate for b, and as algebra goes, what we can do here is we can see that b vector is equal to c vector minus a vector. Now, because we are given them in magnitude and angle form, we're actually going to be a little bit easier to deal with. This is going to be easier to deal with if we have if we get it into component form, rectangular component form, I and j form, is what we're looking for. So for a, to convert it, is, well, the I component is going to be horizontal, and that's going to correspond to a cosine. Okay, so cosine 37 degrees times 13.5 in the I direction. I'll write the units outside. And in the j direction, it's also going to be positive. It's going like up towards the upright. So, but it was going to be sine. Okay, so this is going to be plus sine 37 degrees times 13.5 all meters. And to get numerical values for this, let's calculate that ASAP fast. Cos 37 times 13.5, I got 10.78i, and then the same thing but with sine 37 times 13.5, I got this is plus 8.12 in the j direction, all meters. Okay, and we're going to do the same procedure for the C, except notice how we are going towards the bottom right, the bottom left. That means we have to have a negative y direction and a negative x direction. Okay, so we're going to have negative terms here. So we'll use the smaller angle, the 26.5 degrees, because and we'll just make our sign adjustments as we go. So, but we know both are going to be negative, so yeah, we'll just do that. So this will be cos 26.5 times 15 in the I direction, minus, because we're going towards the bottom left, sine 26.5 degrees times 15 in the j direction. And that whole thing is meters. Cool, so let's multiply that out. Cos 26.5 times 15 negative 13.42 in the I direction, and then minus, now let's find the sine of that. Sine is going to be minus 6.7, wait, 6.6, oops, 6.69 in the j direction, and that is all in meters. Okay, now we have to do c minus a to find b. Minus a. Okay, so the c component is going to be negative 13.42 minus the a component, which is 10.78. That's I. And then for the j, we will have minus 6.69 minus 8.12 in the j direction. And this will give us our b vector. Okay, so we got 13.42 and 10.78 minus 24.2 in the I direction, and then in the j direction we're going to be pretty negative with that one. 8.12 and 6.69. That's going to be 14.8 in the j direction. Okay. No, I rounded them earlier, but I'm pretty sure that they would like perfectly line up to be these nice and easier numbers. Cool. So it's asking for the magnitude of b. So to find the magnitude of b, what we will do is represent it like this. This is going to be a Pythagoras theorem type of situation. So it's going to be negative 24.2 squared plus negative 14.8 squared. And that shall be the magnitude. And what will this be? This will be under the root 24.2 squared plus 14.8 squared. And that is 28.37 meters. And it's going to be positive. Magnitudes are always positive. Okay, so that's good. And to find the angle, well, we have to find the inverse tan of this. So the inverse tan is going to be the y component divided by the x component. So the y component is negative 14.8. And the y component and the x component is negative 24.2. Tan inverse. Okay, that's important. 18.8 divided by 24.2. And my calculation for this is 31 point, just round it off, it'll be 31 degrees. And this is 31 degrees, but we know that we are going in the down left direction. So we know that this has to correspond to 31 degrees this way, which is going to correspond to 180 degrees plus 31 degrees, which is equal to 221 degrees if we are going this way. Okay, so that's going to be the angle of B and the magnitude of B. The calculations here are congruent with mine, so that's awesome. So here, the above solution is good. Awesome. Big high five.